Welcome to the deep dive into advanced Python functions, where we turn ordinary function calls into powerful, dynamic interfaces. Mastering args and keyword arguments isn't just about syntax. It's about writing flexible, readable, and future-proof code. Today, we'll unpack the core concepts and tackle the notorious Mutable Default Argument Trap. Before we dive into the code, join our Discord community. This isn't just a place for questions. It's where you can get help and support, learn in teams, and build crucial soft skills like collaboration and communication. To become part of this powerful learning network, just click the link in the video description. Let's learn and build together. First, a quick recap on function arguments. Python functions use positional arguments, specified by order, and keyword arguments, specified by name. Default arguments let us define parameters with a fallback value, making them optional. They must be placed after any non-default required arguments in the function signature. Now the first big concept, args. The single splat operator collects any number of extra positional arguments into a tuple. This is perfect for utility functions like a custom logger or a variable sum function. Next, keyword arguments. The double splat operator collects all extra keyword arguments into a dictionary. We often use this to accept configuration settings or optional parameters like in web framework functions. Let's see this in action. Here's our keyword arguments function. We pass user equals Alex and role admin. The function receives and prints the dictionary user Alex role admin. A common and powerful inverse technique is unpacking. Using splat or double splat during the function call unpacks an existing iterable or dictionary into arguments. Now let's address the most common function pitfall for Python developers, the Mutable Default Argument Trap. If a default argument is a mutable type, like a list or a dictionary, the object is created only once when the function is defined. Subsequent calls without passing a new value will use and modify the same object. The fix is simple. Use none as the default value, then check for it inside the function and create the mutable object at call time if needed. This is the correct pattern. Now we move into canonical argument order and hierarchy, starting with the strict rules Python enforces when defining functions. The order is mandatory. Standard positional, then defaults, then args, then keyword-only arguments, and finally keyword arguments. Violating this order results in a syntax error. This hierarchy determines how arguments are prioritized. For example, a value passed positionally will bind before Python even looks at args. Let's master keyword-only arguments, or KWOA. By placing a single lone asterisk in the signature, we force all subsequent arguments to only be passed by keyword. This is vital for API stability. Similarly, the less common positional-only arguments, POA, denoted by the /, forces parameters to be passed only by position, completely disabling their use as a keyword. This allows library authors to rename internal parameters without breaking external code, a huge benefit for maintainability. The expert technique that ties all this together is argument forwarding. This is the secret sauce for building generic wrappers and decorators. We write a wrapper function that accepts all possible arguments using args and keyword arguments and then immediately passes them to the target function without knowing what they are. Let's build a simple wrapper function to log when a greeting is being generated. Our wrapper function accepts args and keyword arguments, and its only job is to call the original greeting function using the forwarding syntax. Notice the wrapper, def wrapper args keyword arguments. Inside, it immediately calls greeting args keyword arguments. It doesn't know the names of the arguments, but the splat operators handle routing them perfectly. We can call this wrapper with any combination, positional, keyword, or defaults, and the arguments are safely forwarded to our target function every single time. This is the foundation of every powerful Python decorator. Finally, for advanced readers, type hinting with variadic arguments is crucial. We use typing.any or typing.sequence to properly tell static analysis tools what we expect within args and keyword arguments. Type hinting for these flexible arguments is crucial. It gives your IDE and static checkers a map, improving readability, catching bugs before runtime, and enabling better autocompletion for complex variadic functions. For a final challenge, try to write a function that takes a required positional argument, a required keyword-only argument, and uses args to collect any extra inputs. This will test your full understanding of the order. For further extension, research how inspect.signature in the standard library can be used to dynamically introspect and validate function arguments at runtime. With these tools, you are now equipped to design Python APIs that are robust, flexible, and fully modern. Before the final summary, remember that every course includes supplementary materials, an auto-assessed quiz, a real-world coding challenge, a concise summary takeaway, and all the Python code used here as a dedicated GitHub repository. All these resources are available to you in our Discord server. To access everything and join the community, please check the link in the video description below. Let's quickly summarize our core takeaways. Remember to use args for positional collections, keyword arguments for keyword collections, and always use none to safely handle mutable default arguments. If you enjoyed this Python masterclass, don't forget to like this video, subscribe to the channel, and comment below what you want to learn next. Our next lesson is Lambda Functions and Map, Filter, Reduce.